Morning Algebra 2. Today we are going to do 2.1 and 2.2 Apex notes. We are going to combine the notes. So let's talk about some vocabulary. So 5 and -5 are the square roots of 25. The reason is that if we square 5, so 5 times 5, we get positive 25. And if we square -5, so -5 times -5, then we get positive 25. Remember that when you're putting this into your calculator, if you put this into your calculator, you're going to wind up with this because it's going to square the 5 and then plop the negative sign out front. So you need to make sure that you're being really careful with those signs and parentheses if you're putting stuff like this into your calculator. You won't be using your calculator a whole lot for this chapter. But for this right here, you need to remember that for future use, okay? So 2 is the cube root of 8 because 2 to the third power equals 8. 2 and -2 are the fourth roots of 16 because 2 to the fourth equals 16 and -2 to the fourth equals 16. So that pattern continues. So A is the nth root of B if this is true. So remember that taking a root is opposite of squaring or cubing a number. Okay, so the nth root of a real number, A, can be written as the radical expression, nth root of A, where n is called the index of the radical. So that's the cube or the fourth or whatever root. And A is called the radicand. So when a number has more than one real root, the radical sign indicates only the principal or positive root. Okay, so we're gonna do some problems like this, and you have to remember that if there is a radical symbol there already, not one we are adding, but one there already, we're only taking the positive square root or positive root. Okay, so this radical sign, okay, in this case means the square root, and inside of this is called the radicand. Okay, and if there's a number right there, that's called the index. Okay, so and we'll just put an n there, okay, so that it looks the same. Okay. So you don't have to remember this, but you want to kind of keep in mind these rules, okay, or these guidelines. So if it's an odd index, it's got one real root. Okay? So in other words, if this number is, a 3 or a 5 or a 7. If it's an even index and the number inside is positive, then it's got 2 real roots. If it's an even index and the number inside is negative, then it's got 0 real roots. Okay? And if the radicand is 0, then it's just got 1 root. Okay? So let's take a look at this. And this odd index here, it says 1 real root. Okay, so that's gonna kind of depend. So once again, let's take a look and show you how this works and why. All right, so the fourth roots of 81. In other words, we have some value to the fourth power has to equal 81. Okay? So we need to figure out what that power or what that number is. Okay? So in this case, our index is even, our radicand is positive, so there's going to be 2 numbers. Okay, so now we need to find out what is the fourth root. Well, I know the square root of 81 is 9. Okay, so it's going to be something less than that. So let's try 3 to the fourth power. So 3 times 3 times 3 times 3 does give us 81. So we know that it's going to be positive 3, but keep in mind that -3 times -3 times -3 times -3 also equals 81. So our answer then is going to be plus or minus 3. Okay, let's take a look at the next one here. So cube roots of -125. Okay, so this is an odd index, so it's only going to have 1 real root. Okay, so we need to find out what number times itself 3 times gives us negative 125. Well, here's the deal. If this is a negative sign, okay, then it's going to have to be a negative number because it's going to be negative some number, right, times negative some number. That gives us a positive times negative number. That's going to give us that negative. Okay, so now we need to find out what it is. Okay, well, the square root of 100, okay, is, or 121 is 11. So we know it's going to be less than that. Okay, so now we can work from there. We can say, well, then I know it's got to be less than 11. So I know just off the top of my head that it's going to be 5. Okay, and you want to probably try to, learn some of these because some of them you're going to be using quite frequently. Okay, so negative 5 times negative 5 times negative 5 is negative 125. So our only answer here, our one real root, is negative 5. Now let's go on ahead and look at the 6th root of 729. Okay, so for negative 729, I'm going to go on ahead and take the square root of that. Okay, so if I take the square root of positive 729, I get 27. Okay, so now I'm going to take, so if I have 27, okay, then I know that it's less than 27. So I can start trying things. And as we work through these, you'll get a little bit better at also seeing some patterns here. So 27. Okay, well, if I do 3 to the 3rd power, that gives me 27. Okay, and then 27 squared gives me 729. Okay, so my answer then would have to be, if I'm going to get a negative, a radicand, right, for an even index, right, it's not going to have any real roots. So for a positive 729, I would come up with 3. But remember, this was negative, and we can't take the square root of a negative number and get a real answer. We would get an imaginary answer, which we will talk about more later in this chapter. Okay, so this is going to be no reals. Okay. So the square root of 64, this one right here, what multiplies to 64? Well, plus and minus 8. Okay. However, because, I shouldn't have put the box around that, because I have the square root sign already there, I'm only going to take that positive. Right? Remember, if the square root sign's already there, I'm only taking the principal root or the positive root. And then this last one is just a review so that you guys can remember how to simplify this. So we're going to simplify the square root of 45. Okay, so that's going to break down to the square root of 9 times the square root of 5. Well, the square root of 9 is 3. So that becomes 3 times the square root of 5. And you guys have already seen that, and we'll talk about it more later, but I wanted to remind you about that simplifying because it is something that you're going to use. Okay? So let's talk about rules of exponents. Okay, so product of a power rule. If you have this, so these are if you have the same base. In other words, the number that you're raising to an exponent is the same. Okay, so here, if I had 3 squared times 3 to the 3rd, okay, that would equal 3 to the, and I would add these together and get 5th. Okay, here, if I'm dividing, that means I'm subtracting them. So if I have 3, we'll say 3 squared over 3 to the 1st, that means I subtract those numbers and I'm just going to get 3 to the 1st. So here, a power to a power. So 3 squared to the 3rd power, I'm multiplying those. So I get 3 to the 2 times 3, which is 6. And power of a product property. Okay, so here, really all I'm doing, if I have multiplication of 2 different bases, okay, and I'm raising the whole thing, I'm going to really distribute that exponent. Okay, so if I have 3 times 2 to the 4th, that's really going to be 3 to the 4th times 2 to the 4th. Okay, and I can't do anything with those because these bases are not the same. Okay, so I could solve it, but we're going to get into where we're using X's and stuff. So I'm just going to leave it like that for now. And the same thing, so power of a quotient property. So I'm just distributing this power to both of those. Okay, so if I have, I don't know, 3/2 squared, that would be 3 squared over 2 squared. In this case, I could simplify that, but I'm not going to. All right, so 3 squared would be 9 over 2 squared, which would be 4. And then the last thing is that we want to remember, and this is really important, we never want negative exponents. Okay, so we never leave exponents negative. So if I have a to the negative exponent, I'm just going to rewrite that as its reciprocal. Okay, so that would be 1 over a to the m. So if I have, I don't know, 3 to the -2, that would be 1 over 3 squared. Okay, and the same thing here, if I start with a fraction and I have a negative exponent, so 2 to the -3rd, then I just flip that, take the reciprocal, and that exponent becomes positive. Okay, so by taking the reciprocal, it makes those exponents positive. And once again, we've talked about this before. It's nothing new, but I wanted to remind you guys how to do some of this, because we're going to get into a little bit more difficult problems. So let's go on ahead and take a look at rewriting exponents. So this is something that you have not seen, at least not as much. So we are going to rewrite exponents. So it says a rational exponent is an exponent that can be expressed as m over n, so as a fraction, where m and n are integers. Radical expressions can be written by using rational exponents. Okay, so here, if I have a to the, oh, let's not use a, sorry. Let's do 3 to the 2/3. Okay, I can rewrite that as 3, okay, to the 2nd power, and that would be the cubed root. Okay, the way I like to remember this is I always think of some number to the 1/2 power. So the 1/2 power is the same thing as square root. Okay, and so that just helps me remember that whatever's on top goes on the inside, and whatever's on the bottom goes on the outside. Okay. All right, so let's go on ahead and rewrite some of these and do some simplifying. Okay, so we're going to rewrite this, and then some of them we're just going to simplify. So and practice our math here. So 25 to the 3/5 times 25 to the 2/5. Okay, well, we're going to go on ahead and add those. So 3/5 plus 2/5, because we're multiplying, is going to be 5/5, which is just going to be 25 to the 1st power, which is just 25. Okay, let's go on ahead and do the next one. So the next one is division. So we're going to subtract. So we're going to do 9/4 minus 1/4. We've made these all the same denominator, so we don't have to worry about changing denominators. Okay, so now we're going to do 9 minus 1 is going to be 5 to the 8/4, which is really 5 squared, which is really 25. Let's take a look at this next one. So this next one, we're going to take 1/3 minus 2/3. So we're going to get 8 to the -1/3. So we're subtracting 1/3 minus 2/3 gives us -1/3. Okay, so this is one where you have to remember, number one, we never, ever, ever leave a negative exponent. So the first thing I'm going to do, this whole thing is over 1. I'm going to write the reciprocal. So the reciprocal becomes 1 over 8, and then my exponent becomes positive. Okay, so 1 over 8 to the 1/3. Okay, but now I want to rewrite this as a radical. Okay, because that's what it says to do here. Okay, we're simplifying or rewriting. Okay, so now that's going to become 1 over 8 to the 1st power, and it's the cubed root of that. And now the cubed root of 8 is 2. Okay, so I can simplify this even more. So this simplifies down to an actual number there. Okay, and you guys are going to have to show me, work on this. I'm not going to let you use a calculator to do this because I don't want these in decimal form. These need to be in exact form. Okay, so 11 to the 6 and it's the cubed root of that. So we're going to take 11 to the 6th, and it's the cubed root of that, which gives us 11 squared, which is actually 121. So this is going to stay together. So 7 to the 3rd divided by 4. Okay, so that exponent just becomes a division. Okay, and there's nothing that we can do there. Well, we could, but we're not going to. And we're not going to simplify that further. So we could actually take it to 7 to the 3rd power and then take the 4th root of that. Okay. All right, so that is all for your 2.1 notes. Let's go on ahead and move on to 2.2. There will be 2 separate worksheets for this, but let's go on ahead and do the notes together today. So this next one says we're going to write before or after in the blank. Then we're going to write the radical expression correctly. So if a radical is multiplied by a number or a variable, we put that number or variable before the radical sign. So here, this is showing us the square root of 3x. Well, it's really hard to tell if that x is under the radical or not. We don't want to write these this way. We're going to write it as x times the square root of 3. Or if we had something like the square root of 3 times 5, we would actually write it as 5 times the square root of 3. So that number or variable always comes first. Okay. So we're going to talk about some properties also. Okay, so for any value of a variable expression a, if we take the square root of a squared, okay, then we get the absolute value of that number. So remember that because this value is squared, it's going to be a positive value. And if we're taking the square root of that, then it has to remain a positive value. So the square root of x squared would be the absolute value of x. In other words, it's the positive. It's that positive root that we're looking for. So for any non-negative values, okay, of a variable expression b, a square root of b squared equals b. So in other words, this square root sign here and this squared sign are just undoing each other. Okay? So here, the square root sign and this squared are just undoing each other, and we're going to wind up with x plus 1. But notice it says that x has to be greater than or equal to -1. That's because we cannot have less than 0 in here, because that would give us an imaginary number. Okay, so for non-negative values, and that's where we start talking about our domain. Okay, so our domain is x has to be greater than or equal to 1. If x is not greater than or equal to 1, so if x is 0, right, then I'm going to wind up with, to -1. So let's see, if x is -2, then I'm going to wind up with the square root of -1, and that's an imaginary number. So right now, we're not dealing with imaginary numbers. Same thing for any non-negative, okay, so it has to be positive. Variable expressions a and b, if you multiply them together, you can just rewrite them under the same radical there. Okay? So the square root of x times the square root of 2x would be the square root of 2 times x, which is the square root of 2x squared. Okay, but remember, our domain has to keep both of these as positive numbers. So in order for this to be a positive number, it has to be greater than or equal to 0. And in order for this to be a positive number, it has to be greater than or equal to 0. Okay, and it can, when I say a positive number, it can equal 0 as well, because remember, we can take the square root of 0 and we get 0, which is a real number. Okay. The same thing here for any non-negative variable expression a and a positive variable expression b. Okay, we have to have this. Now notice that the b has to be positive. It cannot equal 0 because we cannot divide by 0. Okay, so our denominator in this case has to be equal to at least something greater than 0. Okay, even if it's a decimal, even 0.2 is fine. It has to be greater than 0. Okay, so here, for this to be non-negative, the top to be non-negative and the bottom to be positive, this x has to be greater than or equal to 0. And here, okay, this has to be -1. at least, well, I guess negative 0.99999, right? Because it can't be 0. So we're going to take both of these together, and because the biggest value is 0, that's what we're going to keep. And here we can rewrite this as the square root of x over x plus 1. Okay, so remember, take a look at this. Okay, this one is x has to be greater than or equal to 0, and this one is x has to be greater than -1. Okay, so we're going to take the one that encompasses both of those. Okay, so if I draw a number line, here's my -1, here's my 0. So one of them has to be here and the other one has to be here. So we're going to take the one where they overlap, okay, which is greater than or equal to 0. Okay. So let's look at multiplying radical expressions. So we're going to have to FOIL these just like we do for binomials. These are still just binomials. Okay. The only difference is now there's a square root symbol in it. Okay, so we're going to do first. So square root of x times square root of x is square root of x, right, times square root of x plus -3 times square roots of x. And now we're going to do our outer. Oh, I guess that's our last. So our let's do our inner. So plus 2 square roots of x. Yeah, I never follow these rules. I always do them just willy-nilly. And then 2 times -3 is -6. Okay, so let's go on ahead and rewrite this. So this is going to be the square root of x times x, which is really the square root of x squared, which is really x. Okay, so our first term is going to be x. Let's combine our like terms. Okay, so here, -3 times square roots of x plus 2 times square roots of x. Okay, so these are your variables right here. And if they're exactly the same, then you can combine them. And we're going to get into that in more detail in the next chapter or section. I don't know why they give these examples, but don't explain it beforehand. So, but we are going to get into that in a little bit more depth. So minus the square roots of x, because -3 plus 2 is 1, okay, -1. And then we have our -6. So that is our final answer. But remember, we cannot have any negative square roots. Okay? So when we do this, we have to make sure that everything is at least 0. So we can go back to this original expression here, okay? And the square root of x, okay, for both of them has to be greater than or equal to 0, which means that x has to be greater than or equal to 0. So really what we do is we set whatever's inside here equal to greater than or equal to 0 in this case. Okay, for division, it's going to look a little bit different. Okay, so let's rewrite this division problem. So we're going to have 12x to the third over 3x, right? And that's division. Okay, so now let's go on ahead and let's combine them. So 12x to the third over 3x, and that's all a square root. Okay, let's simplify what's inside here. So 12 divided by 3 is 4, and x to the third minus, right, 1, because that's a 1. So 3 minus 1 is x squared, and we still have the square root there. Okay, well, now we can break these apart. So just like we were able to on this last page here for multiplication, just like we were able to combine them, we can also break them apart. Okay, so let's break them apart, and let's say the square root of 4 times the square root of x squared. Well, the square root of 4 is 2, and the square root of x squared is x. Okay, so that's going to be our answer. Okay, but we have to find out what our domain is. Okay, so let's go back to this original problem right here. Okay, so remember that our numerator has to be a non-negative number, which means 12x to the third has to be greater than or equal to 0. So let's solve. So divide by 12. X to the third has to be greater than or equal to 0. So now we can take the cube root of both sides, and x has to be greater than or equal to 0. But now we need to deal with this 3x. Okay, so remember that our 3x has to be a non-negative, and it can't be 0 also. And so we're going to set 3x greater than 0, divide both sides by 3, and x has to be greater than 0. So now the bigger of the two is x is greater than 0. So that's our domain for this problem. Okay, so let's go on ahead and finish this up. So this is just the quotients and how to find the domain. So the first thing that you need to consider is each radicand's possible values of x. So we're going to take this one. So if we're looking for x plus 3 divided by 1 minus square root of 1 minus x. Okay, first thing we're going to set x plus 3. It's our numerator. So it has to be greater than or equal to 0. So I'm going to subtract 3 from both sides, and I get x is greater than or equal to negative 3. Here, I have the square root of 1 minus x, and that's my denominator, so it has to be greater than 0. Okay, so now I'm just going to add x to both sides. I just have to get them by themselves. So 1 is greater than x. Okay, so I know some people don't like looking at it this way, so let's just flip this whole thing. Okay, so these are our two individual domains that we have. Now, x is greater than or equal to negative 3, and x is less than 1. Okay, so x greater than or equal to negative 3, x is less than 1. So here, it has to be, remember, where they overlap. So if I draw a number line here, here's my negative 3, here's my 1. Okay, this one's going to go this way, and this one's going to go this way. Well, this is where they're going to overlap. Okay, so my answer then is going to be negative 3 is less than or equal to x, which is less than 1. Okay, because I have to remember that it does not include that, and it does include that one. Okay, so that is my total domain. So I want to look at my each individual part separately, just like we did up here, okay, and then see where do they overlap. Okay, so in this case, from 0, 1 was an open circle and 1 was a closed circle. So they overlap at the open circle, right? Because this right here means that it does not include it, okay, which is why we did just x is greater than 0. All right, so that is it for 2.1 and 2.2. I will see you guys next time. Have a great day.